This video is about modeling direct, inverse, and joint variation. These are all different ways that variables can be related to each other. The first is direct variation. Direct variation between two variables means that as x gets bigger, y also gets bigger. Or as x gets smaller, y also gets smaller. The equation is going to look something like y equals ax, where a stands for some constant. So for example, y equals 3x. That would be a direct variation equation because as x gets bigger, y will also get bigger since it's just x multiplied by 3. So in this case, a is called the constant of variation. And like I said, it's going to be some number. Now, it can be a fraction, it can be a whole number, but it's something that's going to be multiplied by x to give you y. So this is an example of x and y being related directly. So the examples that you'll have to do, it's going to tell you the variables x and y vary directly. Write an equation that relates x and y, and then find y when x equals 12. So this is a two-part question. It wants us first to write an equation that relates x and y, and then it wants us to find y when x is 12 using our equation. So we're going to have to get two things here. So we know that it's direct variation, so we're going to start with the equation y equals ax. And then notice in example A here, they give us an example of an x and a y value. So y is 8 when x is 4. So rather than writing A4, I'm going to write 4a. It just looks smarter. And what we're doing here is trying to find out what is a, the constant of variation in this example. So solving this equation for a, we discovered that a is 2, which means we've done the first part of what it wanted. To write the equation that relates x and y, we're going to write y equals 2x. And I'm going to put a box around that because that actually is half of what the question wants to know. It wants to know the equation that relates x and y. Then it wants us to use our equation to find y when x equals 12. We're going to change x to 12, solve for y equals 24, and I'll also put a box around that. That is the second part of my answer. Okay? So we came up with the constant of variation, wrote the equation using that a, and then plugged in 12 for x to figure out our new y value. All right, let's try this next example here. Still direct variation, so I'm going to start with the equation y equals ax. This time y is negative 10 when x is, oops, I like to write the number first and then a. Okay, so 2/3 a. To get rid of this 2/3, we're going to divide both sides by 2/3. We'll multiply by 3/2. This side comes out to negative 30/2, which is negative 15. So that's our a value, which means I have enough information now to write the equation y equals negative 15x, because that was my a, that was my constant of variation. Put the box around that, that's half the answer. Now it wants us to find y when x is 12 again. So we'll take our equation, plug in 12 for x, negative 15 times 12, y equals negative 180. That's the other part of the answer. Then we come to inverse variation. So now, as x gets bigger, y is going to get smaller. Whereas x gets smaller, y is going to get bigger. So how do we show that in an equation? We have to get fractions involved. So this time, instead of y equaling a multiplied by x, it's going to equal a divided by x. And a is still the constant of variation. Now what happens here is as x gets larger, y is going to get smaller. It's like dividing a pizza into more and more pieces, right? Each piece gets smaller. So that's what's happening in an inverse variation equation, a over x. Let's do some examples. Now it's telling us the variables x and y vary inversely. Right? On a test, I would probably bold this or underline it so that you pay attention to what type of variation is it. If it says inversely, then you want to start with the equation y equals a over x and plug into this to figure out a. Our first y value is 3, and our x value is 4. Which means that a is 12 in this example. We can write our equation y equals 12 over x. That's our inverse variation equation for this example. And it wants us to evaluate now, find y when x equals 2. So we can plug in 12 over 2, which simplifies nicely to y equals 6. That's the second part of our answer. Okay? try it again with a fraction here. Start with the inverse variation equation. Always start with the formula. Seems like an extra step, but it really helps keep you organized. Okay, so y is 12. We don't know a, that's what we're trying to find. The first step. The x is a half. When I multiply both sides of this equation by a half, we figure out that a is 6, which gives me enough information to write my inverse variation equation, y equals 6 over x, found a. And then we plug in whatever wants us to plug in for x, which in this case is still 2. So we'll plug in 2 down here. And y equals 3. That's the second part of the answer. Okay? When you're looking at a table of values, you may be asked to determine whether you're looking at direct variation or inverse variation. The way that you can figure this out quickly and easily, without doing any guessing and checking, is to look at your two formulas. For direct variation, the equation is y equals ax. For inverse variation, the equation is y equals a over x. Now, in both of these equations, y and x are on opposite sides of the equation. So if we can get the y and the x together, figure out the relationship between y and x, that's how we're going to deal with these two tables. Okay? So in the direct variation equation, I want to get x and y on the same side of the equation. So what I'm going to do is divide both sides by x. So that goes away from this side. And another version of the direct variation equation is this: y over x equals a. And to do the same thing in the inverse equation, well, now we're going to multiply both sides by x to get rid of it from the denominator. And x times y equals a. So what we're going to do in both of these tables is try to figure out whether dividing the two variables gets us a constant or multiplying the two variables gets us a constant. That's how we'll know whether it's direct or inverse variation. So we'll try testing out direct first. So as we just determined, another version of the direct variation equation is y divided by x gives us a constant. Constant meaning never changes, and it shouldn't change in the whole table if it's direct variation. So the first thing we want to do is test out this. Is y divided by x going to give us a constant that is true for the whole table? So I'll do 21 divided by 4, which is approximately 5.25 or 5 1/4. Move down a row and try doing 14 divided by 6. If it gets you the same constant, then you're in good shape. You just test it for the whole table and see if it works. Unfortunately, it got us 2.33. Since this is not the same number as the first row of the column, we do not have direct variation here. It would have to get us a constant that was the same throughout the whole table. Let's check if it's inverse variation. To check if it's inverse variation, we do x multiplied by y and see if that gets us a constant. So 4 times 21 equals 84. Excuse me, 84. Then we move down the table. 6 times 14 equals 84. 8 times 10.5 equals 84. And sure enough, this is going to continue through the whole table. Therefore, this table here in example A is an example of an inverse variation. Okay? Because x and y are related inversely in this one. Let's do the same test on example B here and see which one it is. So if we do 16 divided by 4, does that get us a constant that is the same for the whole table? 16 divided by 4 is 4. 11 divided by 5. Well, we know 11 divided by 5 is not going to give us 4. So we already know this is not a direct variation table. Check if it's inverse by using multiplication. So 4 times 16 equals 64. We know 5 times 11 is 55. So this one's not giving us a constant using multiplication or division. So in this case, we would want to say this is an example of neither. This is neither direct variation or inverse variation, right? There's no constant of variation using division or multiplication. And then the third type is joint variation. This is when you have more than two variables. Let's say you have x, y, and z. If it tells you that z varies jointly with x and y, what that means is the equation is going to be z equals some constant a times x and y. Right? Just have one extra variable thrown in there. So if it says varies jointly, you're going to have these three variables. You're going to still have to find a, the constant variation. So it says here the variable z varies jointly with x and y OX is to first write equation, and then to find Z, given those parameters for X and Y. So we start with our joint variation equation. Z equals A times X times Y. A is the only thing I don't know yet. I'm trying to find A, so I'm going to plug in 18 for Z, plug in -2 for X, and 6 for Y. Solve this equation for A. So 18 equals -12A. Divide both sides by -12. And A is going to equal -3/2. Now we've answered the first part of the question. We have to write our equation. Z equals -3/2 xy. All right, we found A. That gives us our equation that relates x, y, and z. Now we need to find z when x is -2 and y is 5. So we'll take our equation, keep A, x is becoming -2, y is becoming 5, and solve this for z. Multiply maybe all across the top, so -3 times -2 is 6, times 5 is 30, and 30 over 2 will be 15. And that is how you use a joint variation equation.